All right, class, let's start the remaining portion of the chapter 9. And this is the class for July 12th, and we'll finish chapter 9 in these lectures. In the last class, we actually stopped here. So we said that if you want to consider out of 4 different decision rules as which one should be the primary decision rule, there are 2 candidates, net present value and internal rate of return. Now, the intuitive question is, like, is these 2 different proxies always give you same decision, or there are situations where these 2 different proxies give you different decisions? So in the upcoming couple of slides, we're going to talk about, is there any conditions, situations, these 2 different proxies can give you 2 different results. So we're going to talk about that. So what are you going to do? We're going to make a horse race between NPV versus IRR. Which one is better in different conditions? In general, like most of the cases, 90-95% cases, they will give you same decision, like accept versus reject. They will give you same decision, accept versus reject. But there may be situations. However, there could be situations where they will not give you the same decision, I mean, accept versus reject. Specifically, there are 2 different situations, to be specific, that NPV and IRR could end up with different results. First one is non-conventional cash flows. So when you say conventional cash flows, it means sign will change once. Let me give an example from here. If you look carefully, you initially invested, and then for coming futures, all are inflows. Initially invested, coming futures, all are inflows. That means sign changed only once. Sign changed, sign never changed again. That is called conventional cash flows. But let's say if I say year 4 CF is equal to minus 55,000. That is a non-conventional cash flows, because initially it was negative, sign changed, positive, sign changed again. This is a non-conventional cash flows. So when there is a non-conventional cash flows, NPV versus IRR will not lead to same decision. Mutually exclusive project. When you say mutually exclusive projects, so they're basically different projects in terms of inflows and outflows, but the main key thing is that you are not able to take both projects at a time. You are not able to initiate both projects at a time. Maybe you do not have sufficient asset to invest in both projects at a time. Okay, so mutually exclusive. If you take one project, you should be able to take the other projects. So for mutually exclusive projects, when they have different cash flow amount, IRR could give you different results than NPV. So in these situations, the answer is always follow NPV. Okay, always follow NPV. So non-conventional, when cash flows sign change more than once. Okay, if this is true, if you solve for IRR, you will get multiple IRR. So that's the problem. So do not trust IRR. So here's an example. Initially, your cost is 90,000. That means year 0 cash flow negative 90,000. Then year 1, 2, 3. If you look carefully, year 1, 2 positive cash flows, year 3 negative cash flows. So negative, positive, negative, sign change more than one. Okay, so that means non-conventional cash flows. If you want to calculate the IRR, it will lead to 2 different IRR. One is 10%, one is around 42.5 or 43%. But financial calculator Excel will give you only one result, 10.11%. If you run this problem in financial calculator in Excel, it will give you one result. But if you check with trial and error basis, check with different rates. If you can remember, in the very first chapter 5, we said that there is no easy way to calculate the rates theoretically. You have to do trial and error. Theoretically, financial calculator Excel will solve it for you, but there is no such a formula like NPV or something else that theoretically you can solve it. So if you do trial and error basis, you have two different IRR. Which one to trust? Is this one right? Or is that one right? Which one is right? We don't know. So that's why for non-conventional cash flows, IRR result is not correct. Then trust NPV, because NPV will give you one result. Okay. Now for a mutually exclusive project. So what does it mean by mutually exclusive project? Two different projects, different cash flows, but for some reasons you are not able to undertake both at the same time. Now here's an example. For project A, you need $500 investment. For project B, you need $400 investment. Let's say you have only $600 of cash flow right now to invest. So that means you can either take project A or you can either take project B, right? Not both. Project 1 cash flows, project B cash flows. Sorry, A cash flow, B cash flow. This is IRR, this is IRR. NPV, NPV. Now, if you look carefully, if you can take both projects, IRR is telling you accept the project because required return is 10%. IRR is telling you accept the project. NPV is also telling you accept the project because NPV is positive. If you can take both projects, but if you can take only one project, A or B, not both, then IRR is telling you accept this one because it has higher IRR. NPV is telling you accept this one because it has higher NPV. What to do? IRR versus NPV. Answer is very simple. NPV tells you how much value you can generate from this project in a dollar basis, dollar to dollar basis. That is $64. $60 for this case, okay? And the objective of corporate manager is to maximize shareholder wealth, stock price in a dollar basis, okay? So that's why if we follow the theory says maximize shareholders wealth in dollar basis. So that's why follow NPV. So the idea is if you cannot take both projects because of any constraint and restrictions, could be one of the example could be you do not have sufficient cash to invest in both, which is 500 and 400, then it's a mutually exclusive projects follow NPV decision rule. Then take project A, okay? Now, when there is a conflict, as I said, NPV measures the increase in value. So you should always use the NPV rule, okay? Now, NPV versus IRR. Conflict could happen in two different situations, non-conventional cash flow and then mutually exclusive projects. If these are situations, follow NPV, not IRR. But for non-conventional cash flows, there is an approximate way to fix the problem, okay? This is called modified IRR. So in modified IRR, this is a way of fixing the problem so that we do not end up with getting two IRRs. We should end up with getting one IRR. Now, what is the modified IRR? So basically, in modified IRR, you have to tweak the cash flows in a way so that finally you do not have cash flows that can change signs more than once, okay? So initially you could have cash flows that have changing signs more than once, but going forward, if you tweak those signs, if you tweak those cash flows, you should not have signs changing more than once. So you have to tweak with the cash flows. So let's talk about this example. Suppose this is the project. If you look carefully, year 0 cash flow negative 60, year 1 cash flow positive 155, year 2 cash flow negative 100. Sign change more than once, okay? Now, if you do trial and error, true IRR 25 and 33. True IRR 25 and 33 because it's a non-conventional cash flow. Now, let's tweak with these cash flows. So that sign change only once. There are three ways we can tweak that: discounting approach, reinvestment approach, combination approach. In a discounting approach, what do we do? We have to discount future cash flows, future outflows to present and add to cash flow 0. So discounting approach, all the future outflows should be discounted today so that so that signs only change one. Let me explain with an Excel. So just to give you some heads up, we are assuming a 20% discount rate for this problem, okay? So let's do this way. So let's copy the cash flow from here, okay? So let's do, we have cash flow, minus 60, we have 155 minus 100. If you look at the initial cash flow, sign change more than once. Discounting approach said that discount this cash flow today so that sign do not change more than once, okay? So assume discount rate %20, just for simplicity, assume discount rate 20%. But you can decide differently depending on the risk of the project, okay? Risk of the project. So what you're gonna do from discounting approach, discount this cash flow 1.2 to the power 2. Makes sense? We take it back to here. So when you take it back to here, no longer exists, sorry. We have to make copy and paste. So what you're gonna do, minus 100 divided by 1.2 to the power 2. Give me a second, there's a missing part. Make sense? So when you convert these future cash flows here, no longer exist. Make sense? No longer exists, but make sure negative some sign, we're just converting it. So what are you gonna do? Sum this cash flows, and now cash flow here, which is 0. Makes sense? Discounting approach. So this is, we're doing discounting approach. Now, if we go to here, second, clear. So cash flow, second. What do you have? Cash flow 0, 129.44 negative. Enter. Cash flow 1, 155, enter. Frequency 1, 0, enter. Frequency 1, and then compute error, compute 19.7466. So 19.7466 makes sense. Definition: discount future outflows to present and add to CF0. Makes sense? Compound approach: compound all cash flows to end, project end. And those are basically inflows. Compound all cash flows to end project life, and then zero all the cash flows in the middle, right? So what you're gonna do, same cash flows. We're doing compounding approach, same cash flows. Okay, just copy this. Copy here. Same cash flows, we have negative 100 here, okay? Discount rate 20%. So go back to the definition. Compound all cash flows except CF0. Compound all cash flows except CF0 to end to project line. So we are not going to compounding this. We are compounding that only. Compounding to the end, which is here, right? So basically 155 to the power 1.2 to the power 2. Make sense? Sorry, I did a typo because we're compounding 1 here, so it will be 1, okay? So 155 compounding 1.2 to the power 1. Now this will become 0, right? And it was positive, so I make it positive. Positive, I make it positive. And that gonna 0. What are you gonna do? Stays the same. Stays the same. Now sum this with some, oh, sorry. Sum this with some that. Makes sense? So this is, if you look here, there is no problem in the convention, right? Sign change only once, right? Go here, cash flow 0, second, clear, go here, 60 negative, enter. Cash flow 1 is 0, enter. Cash flow 2 is positive 86, enter. Now compute IRR, compute 19.7219. So 19.7219. So this is reinvestment approach or compounding approach. Now, combination approach. So what are you gonna do? Discount all outflows except CF0 to present and add to CF0, compound all inflows to end to project life, okay? So what are you gonna do? All these outflows, take it back, all these inflows, take forward, okay? So basically it's a mix and match. Now, if we go here, it's a mix and match. If we go here, take it back here, we have 155 here, right? So we know that from here, if we discount it here, it should be negative 69.44. On that case, that will become 0. And with that note from here, we know that if we compound these, that's going to be 186, and that will become 0. In that case, this makes sense. No conventional problem. So no non-conventional problem. Negative, positive, positive. Not sign change more than once. Go cash flow, clear. 129.44. Sorry. This has to be cash flow 0. 129.44. Enter. Cash flow 1 is 0. Enter. Cash flow 2 is 186. Enter. Then compute IRR. Oops, I definitely make a mistake there. Let's do it again. Cash flow. Clear. Cash flow 129.44 negative. Enter. Cash flow 1 0. Enter. Frequency 1. Cash flow 2 186. Enter. Frequency 1. Compute IRR. Compute 19.8732. So negative 0 positive 19.87. Did you see that? So just follow the definition. Discount, future outflows, discount back today. Reinvestment, all the inflows in the middle compound to future, very end. And now combinations combine. All the outflows, discount today, all the inflows compound to future, so that no change. This is modified IRR. Extension of IRR so that we can fix the non-conventional cash flow problem. Profitability index is an extension of net present value. It said that in a net present value, if you can remember carefully, net present value, you know that net present value is a function of present value of inflow minus present value of outflow. In a conventional cases, we know that at year 0, we have the outflow, and all future, we have the inflow, right? Right? And if you look carefully, this is trying to tell you, say statistical formula, cash flow T divided by 1 plus RT, summation of T goes 1 to N. So that means T goes 1 to N, not 0, T goes 1 to N. T goes 1 to N, okay, 1 to N. So discount all the future cash flow today, and then divide by absolute value of cash outflow today. So if I want to rewrite in terms of NP basis, PI is basically present value of inflows, or you can say present value of future cash flows divided by absolute value. That means if there is negative, don't consider the negative, only consider the raw number. Absolute value of cash flow today. That's it. So we are not deducting. we are actually dividing it. So we're trying to make it in a scaling basis, ratio basis, okay? If it is more than one, that means value creation. If it's less than one, that means no value creation. If you look here, investment today is 10,000. Present value of all the cash flow inflow is 15,000. 15,000 or 10,000, 1.5. But NPV is 5,000. PI is 1.25, NPV is 25,000. Now, using NPV versus PI has a problem too, because PI is scaling it down. So in a scale, it looks lucrative than this one, right? But on a raw basis, this is better. Definition, maximize the shareholder's value in dollar amount, dollar to dollar value. So that's why I follow this one, okay? And always follow NPV then. So the bottom line, so we actually talked about all 6 different decision rules. Bottom line, always follow NPV, okay? NPV is the best choice. In practice, if you go to industry, they do both NPV versus IRR, but NPV is the best choice, okay? That will give you the best results. So that's all so far, and I think we actually covered most of the homework in last class, but let's talk a little bit of the remaining homework. So it's saying that differentiate payback versus discounted payback period. So we know that. What is the difference? Payback, compare how long it's gonna take to get the initial cost back, but discounted payback compare in a discounted basis, the same definition. NPV versus IRR conflict conditions, 2 conditions, non-conventional cash flows, mutually exclusive projects. And we have done these problems today. So this is all so far for chapter 9, and we are good. See you on the next lectures.